Alright, functions, today we started with this warm-up. So go ahead and hit pause and do this warm-up. Okay, so you should have done factor by grouping here, and you get r plus s times p plus q over r minus s times p plus q. We find the big one of the p plus q plus p plus q, and we end up with r, this is our final answer, r plus s over r minus s. They are not the same, so we leave them like that. Okay, and then this one we do keep, change, flip. So I kept this first fraction the same. Where is it? For some reason my mouse stopped working. Okay, so we kept this one the same. We changed this to multiplication. We flipped this one, multiplied by the reciprocal. So we end up with k minus 2 times k plus 2 times 11 times k all over 3k times k minus 2. And then we have the 1 here and the 1's here, and we end up with k plus 2 times 11 over 3k, and we distribute that 11, and we end up with 11k plus 22. So the thing is I would accept both answers. Your book does want the 11k plus 22 over 3k. All right, so just so you know, you have to factor. Every time you do this, a kitten dies, and we don't want to kill those kittens. All right. We're going to start with adding and subtracting rational expressions. We are going to go through this very meticulously, very slowly. So the first thing we're going to do is we're going to add and subtract rational expressions with the same denominator. Then we're going to find that least common denominator. Then we're going to do adding and subtract with different denominators. Okay, so to add and subtract, okay, so do write this down. So if the denominators are the same, you're just going to add them. So if we have 1/5 plus 2 over 5, that is going to equal 1 plus 2 over 5, which is 3 over 5. That's how you do it. Common denominator is 5. If the denominators are different, then we need to find the least common denominator. So if we have 1 over 3 plus 2 over 5, well, we got to find the least common denominator, which is going to be 15. So if we put that over 15, I have to figure out, I multiplied that by 5 over 5. I multiply this by 3 over 3. That's how I get to 15. So when I need them both to be 15, so I end up with 5 plus 6. And then we figure out the answer, which is going to be 11 over 15. All right. So that's how you do it with different denominators. I'm going to go through that a little bit more, but mostly it's the common denominator. Then we simplify, make sure we wrote everything in the lowest terms. If you needed more time on that last slide, go ahead and go back. So you can hit pause. All right, go ahead and get this example in your notes. I don't know what's going on. There we go. So if we have a common denominator, which we do, it is 9. We're going to do 7x plus y over 9, and then that's it. It's already written in the lowest common, or the lowest terms. Okay, we have 8 over 3 x to the cube minus 14, so we're going to get 8 minus 14 over 3x cubed. Then we get negative 6 over 3x. So now right here, students usually miss this, so I want you to notice it. If I had just negative 6 over 3, I could write that as negative 2 over 1. So that's something that we're going to want to do, and you're going to want to make sure you give yourself notes, because this is multiplication. We need to be checking those numbers and make sure they can't be reduced any further. So that is something you're going to want to check. So we end up with our final answer of negative 2 over x cubed. All right, now we have r over r squared minus t squared, and again, we still have that common denominator of t over r squared minus t squared, so we end up with r plus t. Now, can I factor this denominator? I have to ask myself, can I factor it? When in doubt, factor it out. So we are going to factor that. R squared minus t squared is a difference of squares, so we are going to get r plus t and t minus r. Okay, now we have that big 1. This is a 1. This is another thing that students miss. That's going to equal 1 over r minus t. Not just r minus t. That 1 in the numerator does not disappear. It's still there. And I have to have that 1. That's one time. This is one of those times in math where that 1 is important. Okay, so now let's do this. So we end up with that, and we're going to end up with 6 plus x. Now, can I factor that? I can factor this. The factors of negative 18 that add up to 3 are negative 6 and positive 3. So I'm going to end up with x plus 6 and x minus 6. Now, here's something that I will tell you. I typically will write this x plus 6. The reason why I'm going to write that as x plus 6 is it's a little bit easier if I always put my variable first and my numbers after that. If I always do that, it's easier to see that these two things are the same thing, that they're on top of each other. You don't have to do it this way, just like when in the first unit when I said put everything in alphabetical order so that when you're combining your like terms, it's a little bit easier. You don't have to if you're able to do that, but for me, when I was learning this made it easier. So then I have my big 1 right here. And this is another thing where there's a 1, so we end up with 1 over x minus 3. And most of my classes started to find the least common denominator. We got these in our notes. So finding the least common denominator, you want to factor. When in doubt, factor it out. Factor each denominator. Then you're going to find the least common denominator, and how you find, least common denominator. How you find that, it is the product, meaning the answer to a multiplication problem, the product of all the different factors from each denominator. So I think in the beginning I had 1/3 plus 2/5. To find out LCD, the LCD would be, well, the factors of 3 are 1 and 3, and the factors of 5 are 1 and 5. So then I would put 1 times 3 times 5. 1 is twice. 1 is on there twice, so I don't have to do that. So then my LCD would be 15. That's how you find it. With each factor raised, you want to raise it to the greatest power that occurs in any denominator. That's going to look like, so again, factor. It's so important that you factor. You factor. When in doubt, factor it out. Okay, if you have to ask yourself, can I factor this? Yes, you should. You should always factor. Okay, so we're going to look at this one. I want you to notice that we have a semicolon here. We're just comparing these two. We're not doing anything with them, but we're going to find that least common denominator between these two, so the LCD. So the first thing we're going to do is factor. So I'm going to write out the factors of 10. So we got 2 times 5 times a cubed times b to the 5th. And then we have 3 times 5 times a squared b to the 6th. Now we're going to find that LCD. So we've got the 2, that's there. We've got the 3, okay. 5, it's written twice, so there it is. Then we have a cubed. Remember, it's got to be the greatest power that occurs in any denominator. So that's going to be a cubed and then b to the 6th. And then we're just going to do that. We're going to find that product. We're going to do all that multiplication. So we end up with 2 times 3, which is 6, times 5, which is 30, times a cubed, times b to the 6th power. Okay, this is where I ended in almost all of my classes. We are going to start here tomorrow, and then we are going to move into more things. So we are going to be working on this all week. We're going to have some time to do some work in class, but I hope you have a great day, and I'll see you all tomorrow.